We need to sort these numbers by using bubble sort 8, 7, 5, 11, 15, and 2. Now in bubble sort we need to repeat the number of passes, and the total number of passes will depend on how many elements are present. So in this example we are having 6 elements, so we need to do 5 different passes. So in pass number 1, what we have to do, we have to compare adjacent values, and if the first place value is bigger than the second next place, they need to be swapped. So we can see first we compare between 8 and 7. So 8 is bigger when compared to 7, so they need to be swapped. Next we compare second and third element, which is 8 and 5. Here also 8 is bigger than 5, so we need to swap those elements. Next we compare 8 and 11. 8 is smaller than 11, no need to swap. 11 and 15. 11 is smaller to 15, so no swap. 15 and 2. So when we see 15 and 2, 15 is bigger when compared to 2, so they need to swap. So by the end of first pass, in bubble sort, the most highest number of given will go to the end of the array. So we can see that here 15 has reached to the end of the array. So that become part of the sorted order. So we don't have to further process the last element. So we can see that in pass number 1, totally we made 5 comparisons, which is related to total numbers minus the pass number. So here pass number is 1 and total numbers are 6. So 6 minus 1 is 5. So totally we made 5 comparison in pass number 1. Let's go to pass number 2. So in pass number 2 we compare 7 and 5. So 7 is bigger when compared to 5. So it will get swapped. Next 7 and 8. 7 is smaller when compared to 8. So no swap. 8 and 11. 8 is smaller to 11. 11 and 2. 11 is bigger when compared to 2. So they need to swap. So we have finished with pass 2. So we can see that the second highest number reaches to the second last place of the array. So here 11 has reached to the second last place. So 11 and 15 now become part of the sorted order. So we don't have to further process 11 and 15. In this case, pass 2, we have totally made 4 comparisons, which is equal to 6 minus 2. 6 is total numbers present in the array and 2 is the pass number. Let's go to pass number 3. So here again we compare adjacent values 5 and 7, no swap. 7 and 8, no swap. 8 and 2, 8 is bigger when compared to 2, so they need to swap. So 8 becomes part of the sorted order by the end of pass 3. So in pass 3 totally we made 3 comparisons, which is equal 6 minus 3. Let's go to pass number 4. 5 and 7, no swap. 7 and 2, 7 is bigger when compared to 2, so they need to swap. So now the 7 become part of the sorted order. Totally we made 2 comparison in pass number 4, which is 6 minus 4. Let's go to pass number 5. Here we compare between 5 and 2. So 5 is bigger when compared to 2. So we swap it. So both 2 and 5 become part of the sorted order. In pass number 5, we made only one comparison, which is equal 6 minus 5. So when we look at the bubble sort with total n equal to 6 numbers, we made total 5 number of passes, which is n minus 1. Total n minus 1 passes starting from pass number 1 to 5. And in each pass, the number of comparison which we made in the first pass it is 5, in the second pass it is 4. Similarly for the last fifth pass it is 1. So we can see as the pass number increasing, the number of comparison is decreasing. So if we consider k as a pass number, the total number of comparison which we have to make in one particular pass is n minus k, where n is the total numbers and k is the pass number. In bubble sort algorithm, we require total n minus 1 passes to sort an array of n elements. Pass number k requires n minus k number of comparisons. So we can see bubble sort, how the bubble sort algorithm works. Starting from the first index, compare the first and second elements. If the first element is greater than the second element, they are swapped. Compare the second and third element, swap them if they are not in order. Repeat the process until the last element. This process is known as pass, and after the first pass, the largest element of the array occupy the last position in the array. This process has to be repeated for total n-1 passes. Bubble sort algorithm requires n-1 passes to sort an array of n elements. Pass number k requires n-k number of comparisons. Now let us implement the bubble sort algorithm by using a Python program. So here we are writing the logic inside bubble sort method, which takes a parameter a, which is a list of values. First we find out how many values are present by using len function. So n is the total number of values present in a. Now we need to use two loops. First loop is for requirement of number of passes. So we know that we require n-1 passes. So k is an index for passes and I is for doing number of comparison in each pass. So number of comparison in each pass is n-k, because I is going to start from 0. That's why range n-k minus 1. We compare two adjacent values, a of I and a of I plus 1. That means the first place value, if it is bigger than the second place value, we need to swap them. So we assign the values of ai with ai plus 1 and ai plus 1 with ai, so that it will get swapped. Now in the main part, we takes the number of values and number of values from the user inside a variable, a list variable named a1. Then we display a1, then perform bubble sort. After bubble sort, we again display list a1. Try to execute this program. If you are able to execute the program, comment below.